So hello and welcome everyone. My name is Chandra Rosenthal and I'm the Rocky Mountain Director of Public Employees for Environmental Responsibility, and I'm based in Denver, Colorado. And I'm so happy to be part of this webinar in which these three true experts explore animal agriculture and its impacts on our planet. Here at PURE, we're very excited about our Climate Integrity Program. Our aim is to promote climate solutions. And one of the areas that we focus on is public land grazing, because the impacts of this type of agriculture are significant. Currently, about 35% of our public lands are grazed. So that's about 250 million acres, which is the size of about 2 Californias. So PURE works with employees that manage these lands at the Bureau of Land Management and the Forest Service. We hear about the impacts of overgrazing and in some ecosystems, just grazing at all. So we see deforestation, habitat loss, land use conflicts, and loss of native species. That's a lot, but the issues are even deeper. And today we want to explore these issues with you. Addressing the environmental problems associated with animal agriculture is something that too few people want to discuss in this country, but it's a problem that we urgently need to address. And that's why we're delighted to have these three panelists here today. Today, our speakers are going to dig in and we'll learn about impacts to our water, public health concerns, and importantly, how agriculture is contributing to climate change. Our experts today are three amazing scientists: Dr. Sara Vaya, a professor at the University of Maryland; Dr. Kyla Bennett, who I'm proud to have as my colleague here at PURE. She's the PURE Northeast Regional Director and our Director of Science; and Dr. Lydia Jahl, a senior scientist at the Green Science Policy Institute. Thank you, panelists. So the plan is that each scientist will speak and then we'll answer a couple of your questions. So put your questions in the Q&A section at the bottom of your Zoom screen. And then after the last speaker, we'll have a longer question session. So keep the questions coming. Both a recording of the webinar and a PDF of the slides will be available after the webinar, and the slides will have links to citations and resources for you. So we begin today with Dr. Sara Vaya, who is taught at the University of Maryland, Cornell University, and the University of Iowa. She has an active research program with over 50 peer-reviewed publications. I want to note that every summer, Dr. Vaya offers a climate change webinar to the public, and we'll have a link to that available for you. Today, Dr. Vaya will talk about greenhouse gas emissions from animal agriculture and how grass-fed beef is not the solution. She will also discuss how poultry is the best meat from a greenhouse gas standpoint, but a problem for water quality. And finally, she'll talk about industry disinformation. So welcome, Sara. Sorry, Dr. Vaya, you're on mute.
I was so good, you said mute yourself. I did. So great. I'll start again. We're going to talk first about how agriculture contributes to climate change. And this is a global slide. So globally, agriculture causes 18% of greenhouse gas emissions. So you remember that there's three main greenhouse gases: carbon dioxide, which comes from burning fossil fuels and burning wood; methane, which we'll talk about a lot today; and nitrous oxide, which mostly comes from fertilizer, and we'll talk about a little bit today. As I said, agriculture causes about 18% of greenhouse gas emissions. And again, around 4% of that globally comes from methane. About 5.6% comes from nitrous oxide. When we talk about different foods, which is over here on the right, meat causes well over half of all greenhouse gas emissions from food. Dairy, about 18%. And if you scroll around, I don't have a pointer, so you'll just have to sort of look for yourself. But if you look over on the right-hand side, about 3 o'clock, 3:30, you'll see vegetables and grains fruits contribute very, very little to greenhouse gas emissions. Next slide. This slide shows different foods and the sort of where different types of emissions come from. The green on each bar is land use changes. The brown is The brown is hardly shown here at all. It's the sort of rust color comes from methane. That, I guess it comes from the farm. Animal feed, processing, transport, retail, packaging. So when we look down the list of all these foods, you see that they differ a lot in terms of how much sort of what climate impact they have, with beef having the largest climate impact. And when we look at beef, there are two main sources of greenhouse gases. One is from land use change, and that essentially incorporates deforestation and changing to a sort of grazing pattern, like Chandra said, overexploiting public grazing lands. Then there's methane is the largest contributor from beef. That comes from the fact that ruminants like cows don't digest their food very completely. And so they burp a lot of methane, and they also have methane is emitted from their manure. So when you look at beef, the primary two sources of climate impact from beef are land use change and methane from their digestion. A very, somewhat small amount comes from their animal feed, and that's the orange color on the right-hand side of that bar. And when we consider processing, transport, retail, and packaging, those four really don't contribute very much to the greenhouse gas implications of food. So a lot of people talk about how important it is to buy local so that you can reduce the climate impact. Really, transportation does not contribute that much. And so while buying local might be good for some other reasons, support the local economy or whatever, it doesn't make a big climate impact. Lamb is the next most sort of damaging food, again, mostly from methane. Cheese is up there as the third one, but I'd like to draw your attention to the scale down at the bottom. This is per kilogram. So a kilogram of cheese is a lot of cheese, many more servings than a kilogram of beef. Beef from dairy herds has less of an impact because you get both milk and the beef from those herds. Chocolate deforestation has a big impact on that. So when we go down, if you just go down the scale on the left, when you look at pig meat or pork, there's a big impact from the animal feed. That's the red bar. But overall, it's a fraction of the emissions from beef. Poultry, even a little bit less. And then we go down to the very bottom of the sort of the lower 1/3 of the scale, and you see that most plant-based foods have a really low climate impact compared to the animal-based food. So beef's the biggest emitter. Mostly it comes from methane. Crops grown for animal feed contribute to the greenhouse gas emissions because of the fertilizer that's used on the crops, on soybean and on corn. And plant-based products have much less emissions than the animal products. Next slide, please. Next slide, thanks. It's important, no, could you go back? It's important to reduce methane, and this is one reason we really want to reduce beef, because methane has a very short half-life in the atmosphere. So reducing methane can quickly slow warming and decrease the acceleration of climate impacts. Carbon dioxide stays in the atmosphere for hundreds of thousands of years. Methane is 80 times more sort of potent as a greenhouse gas than carbon dioxide for the first 20 years, but it only stays, its average stay in the atmosphere is only 12 years. So its biggest impact is short term. In fact, methane is expected to cause 50% of the warming we're going to have over the next 20 years. So if we can reduce methane emissions, it will really help us over the short term, and reducing beef consumption is one of the main ways we can do that. Reducing methane could buy us time to cut other fossil fuels, although we really don't have very much time to wait on that. So we need to be moving forward on all fronts at once. Next slide. The sources of methane are shown here in this pie chart. Livestock, cow burps, and manure, 36%. Natural gas and petroleum is the next largest contributor. And I think most of you know that natural gas is made of methane, and it leaks a lot in pipelines and in storage facilities. Methane is flared off, that is burned off at the site when they have excess. So there's a lot of leakage of methane from natural gas. Landfills contribute 14% of methane because when you put organic material like food waste and yard waste into a anaerobic, that is without air, landfill, it produces methane. So it's much better. That's one reason it's better to compost the food and yard waste instead of putting it in the landfill. Next slide. Livestock uses a lot of land. So we talked about the sort of land conversion aspect of greenhouse gas emissions. 41% of all US land and 83% of all farmland is used for livestock, either for grazing or for growing the feed. Now, you probably already realized that this picture is not showing geographically where the different uses are, okay? All the forest land is not on the West Coast. All the metal of the country is not used for cows. But it's the relative amount. So 654 million acres is used to raise cattle. And you can compare that. Again, I don't have a pointer, but you can compare that to, food we eat, 77 million acres just to the right, sort of right below Michigan. Livestock feed, that's another 127 million acres. So a lot of land is used to grow beef. If we ate less beef, we could use some of this land, as I say in the words on the left, to restore native forests and grasslands. And that would boost biodiversity. So that's sort of called rewilding, at least by some people. We could grow plant food to feed our human population, which is growing quite rapidly. And Chandra sort of raised the issue of grass-fed beef. I'm not going to talk about that in detail. It's really a topic for another day, but I'll just say grass-feeding beef does not solve the problem. In fact, grass-fed beef emits more methane through burping than grain-fed beef. So it doesn't solve the problem. Next slide. We don't get a whole lot of food value for the farmland we use for livestock. Oh, sorry, that got cut off on the right. This is from a paper that was in Science magazine in 2018. And what we see is we only get 18% of all calories consumed from livestock, okay? And that's even given all that land, and I haven't even said anything about the water, et cetera, that we invest in livestock. We only get 37% of protein from farmed animal products, but it uses 83% of the farmland. And it causes 58% of the greenhouse gas emissions, over half of the water pollution, over half of the air pollution, and about a third of the fresh water use. So we're not getting a very big bang for all the bucks we're spending to raise livestock. Next slide. Another thing that many people don't realize is that beef is responsible for 41% of all tropical deforestation, particularly in the Amazon. So if you look at this picture on the left from Our World in Data, you can see the left-hand bar is the acreage of tropical forest land that is lost to make pastures for beef. Most of this, or over half of this, occurs in Brazil. That's a sort of maroon color. The pink color is the rest of Latin America. So a lot of this is occurring in Latin America. In the Amazon, it's the biggest cause of deforestation in the Amazon. And the picture on the upper right is, several mangy cows that are raised in the Amazon. Much of the grass they're raised on is resulting from illegal deforestation. And this reached a peak during the last administration in Brazil. It's now being, sort of brought down by the new administration there, which is a good thing. But if you're interested in this topic, I really urge you, when you get the resources and you get the PDF of the slides, to look at a few of these papers. They're really I found shocking. The next biggest cause of deforestation is a lot of it is in Indonesia, and that's for tree plantations. I'm sorry, that's cropland for oil seeds, soy, and palm. So a lot of soy is grown on illegally deforested land in the Amazon, and most of that is fed to cattle. In Indonesia, a lot of forest destruction has been done for planting oil palms, and that's what the picture on the lower right is you can see there's some beautiful lush forest in sort of the lower left-hand corner of that picture, but there's all this area that's been cleared and planted in oil palms. And then a little bit of deforestation, 13% is for tree plantations, most of which, of course, are not native trees. They're planted in trees that are suitable for paper and wood. Okay, next slide. I'd like to point out that many Americans buy beef from Brazil without even knowing it. And that's because the USDA lifted a ban on Brazilian beef in 2020. And now JBS, which is a huge meat wholesaler, kind of a shady crowd, supplies Brazilian beef to Walmart, Costco, Kroger, and Albertsons, which is Safeway. So if you go to any of these stores and you buy beef, you may be buying beef that was grown illegally on deforested land in the Amazon. This meat is labeled product of USA because the USDA watered down the country of origin laws in 2016 to exclude beef, okay? So you can buy a package of beef at Safeway or Walmart, wherever, and it'll say product of USA, as long as some person in the US touched that meat by trimming it or even packaging it, it gets packaged as product of the USA, which to me seems very wrong. But the only way that you can be sure that you're not going to be buying Brazilian beef is not to buy beef, or buy less beef. Okay, next slide, please. This is my last slide. Title got cut off on the right again. The top 3 actions to reduce the climate impact of your diet. First, reduce your consumption of beef and lamb as much as possible. Well, Americans don't eat that much lamb, but we eat a lot of beef. And when you change your behavior, or you want to change the behavior of your family, it's always a good idea to start small. Don't go home and announce to your family, well, hey, we're not eating any more beef. That may not go over very well, because the average American eats meat, and most of this is beef, 3 times a day and 7 days a week, 365 days a year. So it's very hard to suggest to someone that they should stop eating beef. I would say, think of yourself as maybe tapering down your beef. And as you learn more recipes for things that aren't beef, then you can sort of advance your program. Don't switch to grass-fed beef. That doesn't solve the problem. So our outcomes: land released for rewilding, less deforestation, et cetera. When you want to eat meat, choose poultry or pork over beef. I already explained that. And when you're trying to make this transition, get your family involved in learning new ways to enjoy food as you taper it off. And especially if you have kids, they can help you find recipes or whatever. And the outcome is, any parent knows this, everything's easier if the kids and the partners are involved. So that's it for me. Thank you very much.
Great. Thank you, Sara. There's a lot to unpack in those slides. We have a great question in the chat about regenerative grazing. So I hope you have time to answer this one. A lot has been written on how cattle grazing on crop fields keeps soil health in Africa. Is there truth to that? And if so, is there any applicability in the US?
Well, a lot of people have suggested that grazing beef improves soil health. I personally don't buy that. I've read quite a bit about it. Beef cattle weigh a lot and they compact the soil. They do, of course, deposit their manure, and that can, to a certain extent, fertilize. But usually there's also some auxiliary feeding of these things, of hay maybe brought in from another place. And so measurements of increasing soil carbon, I don't find very reliable. And the term regenerative is not very well defined. It's just sort of used as anything that's good. And a lot of different things masquerade as regenerative. I don't think there's any way to make beef cattle climate friendly. That's my, my opinion as a scientist. I've read quite a bit about it. We can talk about that more in the questions at the end if you want.
Absolutely. I think that that's a really interesting issue. So maybe we can talk about that more. So now I want to introduce Dr. Kyla Bennett. Before joining PEER, Kyla worked for 10 years at EPA, finishing her time there as Region 1's Wetland Enforcement Coordinator. Kyla first became involved with PEER in the mid-1990s when she became a whistleblower herself. Kyla has a PhD in ecology from the University of Connecticut and a law degree from Lewis and Clark Law School. Kyla's work on toxic chemicals is transforming regulations, and we are lucky to have her at PEER. Today, Kyla will discuss the land use involved in animal agriculture and how it results in the loss of biodiversity. She'll also explore water use and water quality issues associated with animal agriculture. Welcome, Kyla.
Thank you so much, Chandra, and thank you, Dr. Vaya, for that illuminating talk. I'm going to talk, as Chandra said, about biodiversity loss and water quantity and quality issues with animal agriculture. Next slide, please. How many animals get slaughtered for meat every day? These numbers are pretty staggering when you think about this is each day. 900,000 cows, 1.4 million goats. I mean, it just goes on, 202 million chickens. And the reason we're slaughtering so many animals is because humans globally consume 350 million tons of meat per year. In the United States, 12% of people, and these are mostly men between the ages of 50 and 65, eat about half of that, of the US portion of this. The average US resident eats 225 pounds of meat a year. And because of this, we have 92 plus billion land animals per year slaughtered. And why is this important? Because the more animals we have for use in animal agriculture, the fewer wild animals we'll have. Next slide, please. This is a really cool graphic. I hope you're not colorblind because it'll be difficult to see, but this MT is million tons. So you can see that of the biomass, the total biomass of mammals on Earth, humans are 390 million tons, and domesticated animals, mostly cattle, are 630 million tons. There are more cattle by biomass and other farmed animals than there are humans. Look what's left over for those wild animals. On the left in the green, you can see wild terrestrial animals and wild marine animals in blue on the right. That's horrifying. That means that we have lost incredible biodiversity and we are taking over the earth with humans and domesticated animals, including cats and dogs, actually. Next slide, please. And it's not just meat that's causing this loss of biodiversity, it's also dairy. Next slide, please. Per capita dairy consumption in pounds in the US, it's about a little over 600. I think the last time I checked, it was 622 pounds of dairy per year, which is stunning. That's a lot of dairy. Dairy includes cheese, meat, yogurt, milk, things like that, butter. That's a lot of dairy, and a lot of our land is used for dairy cows. Next slide, please. Dairy also results in huge environmental impacts. This chart is great. It talks about the land use, greenhouse gas emissions, freshwater use, and eutrophication of water from dairy. And one of the things, I've been vegan for about 10 years. I've been vegetarian almost my whole life. And one of the things that people always throw at me is, oh, almond milk, it uses so much water. Well, if you look on the freshwater water use, in the bottom left there, yes, almond milk does use a lot of water, but dairy milk uses almost double. So I don't drink almond milk. I'm careful about what I drink. I usually drink oat milk, But you can see that dairy really, really uses a lot of land, results in a lot of greenhouse gas emissions, a lot of freshwater use, and eutrophication of our natural surface waters and streams. Next slide, please. So the loss of intact ecosystems results in the loss of biodiversity. Agriculture accounts, as Sara said, for 70 to 80% of tropical deforestation, which means the permanent conversion of forested land to another land use. And of this, beef, soil, and palm oil are responsible for 60% of that. But the thing that's really important, because this is another thing that gets thrown in vegans' faces all the time, is, oh, you're eating so much soy, you're causing more land use than us meat eaters are. That's not true, because 76% of soy is used to feed livestock, not people. And another 4% is used in industry. So 80% of the soy grown in the world is not used to feed people, but used to feed livestock, which is a very inefficient way to get calories. And over the past 50 years, the conversion of natural ecosystems for crop production or pasture has been the principal cause of habitat loss. And these animals are reducing biodiversity and replacing wild animals with domesticated animals. Next slide, please. So this is very similar to Dr. Vaya's slide on land use, and I won't go into this too much, but you can see that beef, lamb, cheese, milk, pigs, poultry, fish, eggs, all of those animal agriculture things are on the top, and at the very bottom are rice, maize, root vegetables, potatoes, apples, much, much lower impact on the land. Next slide, please. Let's turn to water, freshwater withdrawals per kilogram of food product. Look at that water withdrawal for cheese. I mean, that's crazy. Yes, nuts are up there, and those are nuts that are in trees. If you notice, the ground nuts use far less water. You can see that's below rice. Rice uses a lot, but again, it's mostly cheese, fish, prawns, beef. Uses a ton of water to get your cheese, to get your milk. And you can save a lot of water by eating lower on the eating plant-based meals mostly. If you look down, peas, tomatoes, apples, bananas, wine is in there. Doesn't use much water. That's good. Next slide, please. So animal agriculture uses so much water that a recent analysis showed that just 20 farming families use more water from the Colorado River than some entire Western states. In 2022, which is the last year we had statistics, they used 387 billion gallons of water, or 1 in every 7 drops. And the bulk of that water was used to grow hay for livestock. So agriculture uses 70% of freshwater reserves, and as Sara said, animal products only account for 18% of our calories. This is not efficient. And as climate change gets worse, we're going to have less and less potable water for us to drink and to use for our purposes. We should not be using so much of this in this inefficient manner, which gives us very few calories for our food. Next slide, please. Let's talk about the impacts on water quality. We just discussed water quantity. What about water quality? Here's a confined animal feeding operation for pigs. Next slide, please. EPA defines a large confined animal feeding operation, or CAFO, as at least 700 dairy cows or 2,500 swine weighing 55 pounds or more. One large CAFO can generate as much manure and urine as a large city. This waste is not treated. It is discharged into lagoons, and you can see this lovely picture to the right with that kind of pink or mauve lagoons. That's what they look like. They are that color because of the anaerobic bacteria that are in there. But part of the problem is that these lagoons often leak. They leach into the soil, they leak into our waterways, they contaminate waterways, and if you've ever driven by one of these, they smell disgusting, but they are a real problem with our water quality in this country. And as of 2012, large CAFOs in this country generated 404 million tons of manure, which is over 20 times that produced by all humans in the United States. That's a massive amount of manure, and there's nothing we can do with it. It can't be disposed of in a way that's safe. Next slide, please. What's in these lagoons? We have a lot of nutrients, and as you know, too many nutrients are bad for waters. It's got pathogens. It's got veterinary medicines like antibiotics, lots of heavy metals like zinc and copper, and zinc can be extremely toxic to wildlife. It's got hormones, it's got pesticides, and in the air around these lagoons, you can smell ammonia. There's hydrogen sulfide, one of the reasons it smells so bad, methane, and also particulate matter. So it's not only dangerous for our water, but it's dangerous for our air. Next slide, please. One thing I want to talk about is that climate change is not the problem. Climate change is definitely a problem, but even if we stopped burning all fossil fuels and stopped all of this animal agriculture tomorrow, we would still have a big problem because of our use of natural resources. Climate change is a symptom of ecological overreach or overshoot, which just means that human demand for goods exceeds the regenerative capacity of our natural ecosystems. And if you get the PDF of this talk afterwards, there's a link to a professor named Dr. William Rees, who gives a really nice, short little 7 or 8 minute video explaining ecological overreach. Human consumption is what drives the loss of biodiversity, climate change, extinction, pollution, and water scarcity. Animal agriculture is a huge part of this overreach. It's not the only thing, but it is a huge part of this overreach. So you do have power in what you choose to buy to help the problem. Next slide, please. I really wanted to just show this slide. There's this great website called Earth Overshoot, and it tells you when we have used up all of the resources that we should use for a whole year. And as you can see, in 2023, we used those up in July. So we need more than one Earth to provide all of the goods that we're currently using. We need 1.7 Earths to give us everything that we need. We are heading towards collapse on a number of fronts with the pollution that we have in our water and our air, with the loss of biodiversity. And if you don't understand how the loss of biodiversity can impact humans, indeed it can, I would suggest you look into Dr. Paul Ehrlich's river popper theory. We don't know which species are a keystone species. And if we lose a keystone species, it can have a domino effect across all animals, including humans. Last slide, please. So this is a picture that was taken from a climate change march. And my personal opinion, I'm not speaking on behalf of Peer here. My personal opinion is I don't understand how people can be climate scientists and also eat meat because of these climate changes. 3 things that you can do. You can read labels. Palm oil is very, very destructive, and it's in so many products. Read labels. Don't buy things with palm oil. Reach out to companies that use palm oil and say, please stop. Just read the labels, get rid of palm oil out of your life. Second thing you should do, buy from backyard farms, small family farms that you know use good practices and can help. I'm vegan. My husband and my dogs are not. They eat eggs. I buy eggs from my neighbor. He's got a very small flock of chickens. He's not near a stream. He doesn't have a lagoon that's full of chicken manure. So it's much cleaner. And the third thing is, if possible, engage with other nonprofits like Earth Justice, EWG, all sorts of groups that are promoting tighter regulations of these confined animal feeding operations. Thank you so much for listening to me. I'm happy to take any questions if you have any.
Hi, Kyla. Thank you for that. So we have a question here wondering if you can use animal manure to create biogas, which would help address climate change and mitigate other negative effects of cattle, chicken, and poultry. Have you ever heard of this?
I have heard of this, and I don't think it's the answer for a number of reasons. First, once a cow defecates, the manure is there. It's releasing methane. Also, cows fart and burp, and methane is released that way. So it's a way of disposing of that manure, but burning that is just going to create more greenhouse gases. The only solution to this huge land use and greenhouse gas emission problem is to reduce our consumption of beef. And the other thing I'd like to say is that a lot of manure, especially on farms that are conventional rather than organic, have a lot of PFAS, which Dr. Jahl is going to talk about next. And if you burn that PFAS can become airborne, you can inhale it, and it's very dangerous. So I am not in favor of biogas using manure.
Interesting. Okay. Well, thank you. Thank you, Kyla. So our next speaker is Dr. Jahl, and she's a senior scientist at the Greenhouse Policy Institute, which is a small nonprofit that collaborates across sectors to reduce the use of harmful chemicals in everyday products. Her current work focuses on two chemical classes that have a wide range of health and ecological harms: PFAS and flame retardants. Dr. Jahl has a PhD in chemistry from Carnegie Mellon University and a BS in chemistry from Harvey Mudd. Dr. Jahl is going to discuss how much of our exposure to harmful chemicals like PFAS and phthalates come from the food and water we consume. She'll explore how we can eat in ways that prioritize the climate, water quality, and biodiversity, and also reduce our own exposure. Welcome, Lydia.
Thanks so much, Chandra. Next slide, please. So we've heard a lot about how the choices we make at least 3 times a day can improve our environmental health. But there's also ways that reducing our consumption of animal products improves our own health. Next slide, please. And that's through our toxics exposure. Much of our exposure to harmful chemicals comes through what we eat and drink, and much of this is from animal products. Next slide, please. So our exposure to harmful chemicals in food comes in 2 ways, both directly and indirectly. When thinking about direct exposure, for any plants consumed, this exposure can come through the soil they're grown in, through both rainwater or irrigation water, and also through fertilizers, especially biosolids that can have a lot of contaminants such as PFAS. And then for animal product consumption, again, this can expose the animals directly through their soil, water, and feed, but then the feed itself is also subject to all of the other considerations that I just mentioned for plants. So there's an accumulation factor there as well. And then all types of food are subject to indirect pathways for toxics exposure. This can happen through ingredient processing. So for example, a lot of pasta is extruded through Teflon dyes, and Teflon is a PFAS chemical. We also have a lot of opportunity for harmful chemicals to be added through food packaging itself. So that's why unpackaged food, like the tomatoes on the left of this slide, is your best bet, followed by them packaged in something, plastic being the worst, of course. Glass packaging is better, and then canned foods represent a large opportunity for harmful chemicals to be added. You may have heard of chemicals like BPA, BPS, and similar chemicals. Next slide, please. So animal-based foods do tend to accumulate toxic chemicals a lot more than plant-based foods. This is due in large part due to the fact that many persistent organic pollutant contaminants are lipophilic and therefore concentrate in fats. Some examples of these are flame retardant chemicals, dioxins, DDT, other pesticides, and more. Other harmful chemicals tend to concentrate in blood or proteins, so you can find them at very high levels in animal products, such as PFAS chemicals. And then lastly, many concentrate just due to simple animal physiology. So for example, livers can collect harmful chemicals, so the consumption of animal livers can be associated with a lot higher exposure to harmful chemicals. And then filter feeders like clams or oysters, you can tell by the name filter feeder that those will collect harmful contaminants. Next slide, please. The other part of what makes animal products have higher levels of these contaminants are bioaccumulation and biomagnification. So bioaccumulation happens within a single individual, and it just means over the course of their life, they'll slowly build up concentrations of harmful chemicals when those chemicals can't be excreted very quickly. And then the other part that's very relevant for the consumption of animal products is biomagnification. And this happens across species, from plants to animals to us. So an example shown here is the initial emission of chemicals called dioxins. They are very bad for our health, and they are released when plastics are burned or other materials with flame retardants are burned. So these chemicals can travel through the air and be uptaken into crops, into plants, and have low levels of these dioxins. When a cow consumes a lot of this plant over its lifetime, it can build up some more dioxin. So you can see the dioxin level in the cow is slowly going up into a mid-orange range. By the time that cow is slaughtered and we eat a burger, the dioxin levels are a lot higher. So then when we eat that, we're higher up on the food chain, and so we have higher dioxin levels due to that biomagnification. And then the unfortunate last step that can sometimes occur is transplacental transfer of these contaminants or transfer through breast milk to our babies. And that's why babies can oftentimes end up with higher levels of contaminants than the mothers had themselves. Next slide, please. So one group of chemicals that I'll talk about today are called PFAS, which stands for per and polyfluoroalkyl substances. These are chemicals characterized by having many strong carbon-fluorine bonds. You can see that in the images of these two very popular PFAS, PFOS and PFOA. These carbon-fluorine bonds make them very persistent and very resistant to break down both in the environment and our bodies. And that's why they're often called forever chemicals. So these chemicals are very useful in a variety of products due to those properties, but unfortunately, it also makes them associated with a wide range of health issues, spanning all our organ systems in our body, from certain cancers to increased cholesterol to developmental effects in children. So these are chemicals that we really want to avoid. Next slide, please. So we've known for many, many years that high levels of PFAS can be found in fish. You or I can filter our drinking water, but fish can't filter the water that they live in. And so they can accumulate a lot of chemicals, including PFAS. And we know a lot about how we're exposed to PFAS through diet because of studies that have been done around the world on pregnant women to try to learn about their PFAS exposure, since that's can be very harmful to their babies. So this shows that many different PFAS have been associated with consumption of milk, cheese, meat and eggs, as well as fish. And this has also been shown to be the case in water too. Water makes a difference no matter what food you're eating. And other studies have also shown decreased levels of PFAS with increased consumption of vegetables, which is a very good thing. But one question is whether or not this association with certain foods can make an impact based on our dietary choices. Next slide, please. This hasn't been studied too much, but there was a study a couple of years ago out of Germany comparing vegans and omnivores. And what they found was that there was 54% higher PFOS and 240% higher PFNA in omnivores compared to vegans. And this chart here is showing the sum of different PFAS in these people's blood across the number of years that they were vegan. And you can see that no participants who were vegan for greater than 7 years had elevated levels of PFAS. And that makes sense because PFAS exist in our body for many years. It takes a really long time for them to be cleared out. But if you decrease your major exposure source, which for most people is your food, then over time, you'll decrease the levels of PFAS in your blood. Next slide, please. So it's not just humans and livestock that are exposed to PFAS because of our pervasive use of them in many different product categories. We can see in this great map from the Environmental Working Group that there's wildlife in all our continents and across all oceans that are exposed to PFAS. Next slide, please. So that brings up the question, if vegans have lower levels, what about herbivorous animals? And actually a study came out on this recently, and herbivorous animals do have a lot lower levels. So this chart is showing PFAS concentrations in animal livers. And you can see that herbivores have really low levels compared to omnivore animals, and especially compared to carnivore animals. So this shows that PFAS exposure comes a lot from food, both for humans and for animals. Next slide, please. So it's not just people who eat meat who consume PFAS. PFAS is still present in many different food categories. This is a Guardian article that found 7 out of 8 samples of kale brought in US stores had high levels of PFAS, with the organic kale actually containing more PFAS. So people who don't eat meat still are exposed to PFAS. Next slide, please. But the good news is that fiber seems to be protective when it comes to the amount of PFAS that we absorb into our bodies. So this was a really interesting paper from 3 years ago showing that with each interquartile increase in fiber intake, which isn't actually that much of an increase of fiber intake, on average, people had an 8% decrease in PFNA levels and a 4% decrease in PFOA levels. And that's actually pretty well known that fiber can help decrease absorption of harmful chemicals. And this just showed that it seemed to be the case with PFAS as well. And what's really interesting is that some other papers on PFAS health effects have shown that those health effects occurred only in people who didn't consume enough fiber or enough folate, both of which come from plant-based foods. Next slide, please. What about chemicals besides PFAS? Next slide. So just really briefly, flame retardant chemicals are added to products with an attempt to reduce flammability, but oftentimes that doesn't actually help. And at the same time, these chemicals are often carcinogenic, neurotoxic, and endocrine disrupting. Unfortunately, they also accumulate in animal-based foods. So a Canadian study found them really high levels of PCBs and omega-3 supplements, especially in ones derived from animals high on the food chain, like seals. And there are 2 studies in Norway that found different flame retardant chemicals in fish, in meat, lamb, and margarine. And these are both the older flame retardant chemicals like PCBs and PBDEs, as well as the newer replacement flame retardants like organophosphates. Next slide, please. This was a really interesting study that's looked at 105 different foods in Chinese grocery stores. And you can see that there are very high levels of both the PBDEs as well as newer flame retardants in fish, meat, poultry, dairy, and eggs. So the bottom of both of those charts shows really high concentrations of all sorts of different flame retardant in these foods. Next slide, please. If they translated these to what people would commonly consume within one day, and you can see that even though not a large portion of what people were eating were animal-based foods, it still contributed to 2/3 of their total flame retardant exposure. So this just shows that by reducing our animal product consumption, we can really decrease our exposure to harmful chemicals. Next slide, please. This also occurs for dioxins, which I mentioned earlier. A 1994 estimate was that vegetarian dioxin intake was just 2% that of the general population. That's really noteworthy because of how harmful dioxins are. And then a USDA study not too long after found that omnivore children in the United States may exceed the safe reference dose just by having meat fairly often throughout their week. Next slide, please. And then I'll just end on more indirect exposure for animal-based foods, and that's phthalates, which are endocrine disrupting chemicals that concentrate in high-fat products. So you may think by buying your milk in glass, that's helpful, and that certainly is better. However, phthalates are still found in milk, even when it's packaged in glass, and that's because it's used in the tubing to milk the cows. And that's how you end up with New York Times headlines like this one, "The chemicals in your mac and cheese," because phthalates were found in all mac and cheeses and all dairy products just because of the way our industrial food system works. So next slide, I'll end on some positive notes and things that you can do. So first is obviously to prioritize plant-based foods as much as possible because they do not accumulate harmful chemicals in the same way that animal products do. At minimum, choose low-fat dairy products and trim excess fat off of meat to try to get rid of the most concentrated sources of exposure. That works for things like flame retardants. It works less for things like PFAS. Especially for PFAS, though, you do want to avoid eating animal livers and fish, especially freshwater fish in the United States, because they accumulate PFAS so much. And at the same time, increasing your fiber intake has a wide range of health benefits, including decreasing the absorption of harmful chemicals from your food. When it comes to indirect exposure to toxic chemicals, prioritizing minimally processed foods as well as foods that are packaged in paper or glass is really ideal. And lastly, you really want to store your leftovers in glass and only reheat leftovers in glass or ceramic and never in plastic, because that can help the harmful chemicals leach out. And that's all I have to say for today. Thanks very much.
Great, thank you, Lydia. And now we're going to open it up for questions for all the panelists. So if you could all turn on your cameras. I have one question for all of you, which is one thing that at groups, we are often advocating for additional regulation from the federal government. Animal agriculture is got so many different facets. What do you think would be one of the most effective regulations that the government could implement to address, I don't know which aspect, the pollution or the clean water? What do you all think?
I can start from a toxics perspective. So all of the harmful chemicals that get into our food get there because we're using the PFAS, the flame retardants, for other products, for other things that we buy. And so the most effective policy would, A, make sure that chemicals used are safe before we allow them into commerce, and B, when we learn chemicals are harmful, to restrict their usage as much as possible. And then we'll at least have a chance of having those chemicals not get into our food. Obviously, having tighter regulations around water quality and things like that would help as well. But really, that's a secondary effect. We need to make sure these chemicals aren't used in the first place so that they can never get into our food chain.
I'd like to also answer that question. I agree with everything Lydia said. I would add two really important things are to restore protections to waters of the United States. Our WOTUS decision was, our WOTUS rules were gutted by the Supreme Court in the Sackett decision last year. And right now there are about 50% of our streams in this country that are not regulated. In other words, you can dump animal waste or phosphorus, nitrates, whatever, into these waters because they're no longer considered federally jurisdictional. So one of the things the government could do is to tighten back those regulations and start regulating those waters of the United States so that we don't have discharges into them. The other thing, and this might be controversial, but I'm going to say it anyway, is that I really think that the ag-gag laws have to change. Right now, there are very, very strong gag laws so that people can't bring cameras into slaughterhouses or onto these CAFOs. We get drone footage, but it's very rare that you find out what's actually going on in those facilities. And personally, I think that if people saw what was going on, they would naturally eat less meat. It's like, I think Paul McCartney said that if slaughterhouses had glass walls, everybody would be vegan. And I think that I think it's only fair for not just the animals, but for people to know what's actually taking place in these facilities.
I'd like to say something too. I think that the disposal of manure in these giant lagoons needs to be regulated more because they're constantly contaminating the surrounding areas and the streams, et cetera. I read a really horrifying article over the weekend about a big livestock facility in Arizona that's located, in fact, it's bounded on all sides by lettuce fields. And, the manure, I know, really a nightmare. The contamination from the manure gets into the lettuce, and that's how we get lettuce recalls, et cetera. But people can get, of course, very sick from that, and that just seems like kind of basic thinking. Don't let the manure go into the water supply. So if it takes regulation for that, then that's what we need to have.
Great. And in this last slide, is there anything in particular you guys want to point out?
I mean, I think they're all excellent suggestions. And I think I'd just like to kind of expand on something Lydia just said, which was the reason that we have so many toxic chemicals in our food supply is because of the toxic chemicals that we use in our daily life. So that instance that she showed, the slide about the organic kale having really high levels of PFAS, generally speaking, one would expect organic produce to have fewer toxic chemicals like PFAS and pesticides because organic farms are not allowed to use biosolids, which is just human waste, and it's chock full of PFAS, and that PFAS will get into the meat, the dairy, the vegetables, whatever you have. So if you've got an organic farm, you should have less PFAS. Also, no pesticides means fewer toxic chemicals that way as well. But part of the problem is that so much of our water is contaminated. And not only that, a lot of plastics are fluorinated, particularly number 2 plastics, and that creates a lot of PFAS in the plastic. And those number 2 plastics are recycled. And one of the purposes that they're repurposed for is water irrigation pipes. So we're literally spraying PFAS contaminated water on our crops. The only way to stop this really is to stop all non-essential uses of PFAS. And that's something everybody should be doing, is get rid of your Teflon pans. Don't buy the, aftermarket sprays for waterproofing. Read ingredients. Don't buy makeup with PFAS. Ask questions of the manufacturers of these products to ensure that there's no fluorinated chemistry. That's the only way at this point that we're going to solve this national crisis of PFAS contamination.
Great. Thank you, Kyla. And thank you all of the speakers and all of the attendees. We heard about the extensive impacts of animal agriculture on the environment, the climate, and our health. The impacts are staggering. So hopefully we will leave you today feeling empowered as to how to minimize these impacts and ready to advocate. So goodbye.